In this presentation, we're going to take a tour of the real numbers. First, we're going to drill down into the real numbers to see what's inside, and then we're going to take a look at the diagram on the right and see how it summarizes everything we've learned. So, let's now start with the real numbers. Way down deep in the real numbers, we begin with the natural numbers. Natural numbers are also called counting numbers, and they're the numbers beginning with 1. 1, 2, 3, 4. And you can remember that because it's natural to begin counting things with 1. The next set that we're going to talk about includes the natural numbers, but what if there's nothing to count? If there's like a hole with nothing in it? The whole numbers is a set that contains all of the natural numbers, but in addition it also contains the number 0. And we usually write that as we do at the bottom here. The whole numbers is W is 0, 1, 2, 3, and so on, or it's 0 plus all of the natural numbers. The next set we'll look at is the integers. Now, the integers are all of the whole numbers, so all whole numbers are also integers. But the opposites of the whole numbers are also integers. And there are two ways of expressing this set. One of them is the first one, z, integers, equals ... negative 3, negative 2, negative 1, 0, 1, 2, 3, and so on. Another way of thinking about the integers is expressed the second way, that they are 0, 1 and negative 1, 2 and negative 2, 3 and negative 3, and so on. Note that the numbers that have decimals, like 3.2 or 7.1, or have fraction parts, like 3/5 or 7/9, those numbers are not integers. As an aside, the letter z, which stands for the set of integers, is thought to be from the German word Zahl, which means simple, and also this set is called the set of simple numbers in German. The next set that we'll look at are the rational numbers, designated by the letter Q for the word quotient, which means to divide. The word rational comes from the word ratio, and we know that ratios are calculated by dividing. Now, the rational numbers are all of the integers, so all of the numbers that we've talked about so far, but also the numbers that are the ratios of two integers. So another way of saying that is, if you divide one integer by another integer, the result is always a rational number. So how can you tell if a number is rational? Well, all integers are rational numbers. Now, if the number is not an integer, you can look at the decimal form of the number. And if the decimal form terminates, it's rational. If it repeats, it's rational. If you can write the number as a fraction where the numerator and denominator are integers, then the number is also rational. Now, here's some examples of numbers with terminating decimals. 3.5, negative 8.723, 4.0, 8001, negative 17.12345, negative 8,250,307.11112. All of these numbers are expressed as decimals, and the decimal representation ends where you see it. There are no digits beyond what you see. So those are rational numbers. Here are some other numbers which have repeating decimal expansions, which are also rational numbers. 1.33333 and so on. 8.142857, 142857, 142857, and so on. The 142857 repeats indefinitely. Therefore, this second number is a rational number. And the third number, negative 812.3434343434, and so on. That number is also a rational number. Here are some other rational numbers. 1/2, negative 22 over 7, negative 6 over 109, 18 over 11. All of those are rational numbers because we are dividing one integer by another, and the result is always a rational number. Well, how about the number 3.5 over 8.27? As it turns out, that is also rational because you can write the same number as 350 over 827. You'll find that if you divide 3.5 by 8.27, you'll get exactly the same value as you do if you divide 350 by 827. Therefore, those two numbers are the same, and since it is possible to write 3.25 over 8.27 as a ratio of integers, it too is rational. So now we're going to look at what irrational numbers are. And simply stated, irrational numbers are numbers that are not rational. In other words, they are numbers that cannot be written exactly as a ratio of two integers. Their decimal expansions go on forever, and they do not end, and they do not repeat. Now, one way of getting an irrational number is by taking square roots. And if the square root of a whole number is not an integer, then it's irrational. So for example, the square root of 2. The square root of 2 is not an integer, so it is irrational. The square root of 5 is not an integer, so therefore the square root of 5 is irrational, and both for the square root of 2 and the square root of 5, if you were to write out their decimals, they would go on forever, they don't repeat, and obviously they don't end. Now the square root of 4 is a rational number because the square root of 4 equals exactly 2. You also may know that pi is an irrational number because its decimal digits go on forever and they never repeat a pattern. So those are the real numbers. Now another way of looking at the real numbers is to look at them in box form here. The smallest set is the set of natural numbers. Next, we have the whole numbers, which include all of the natural numbers, but in addition, the number 0. The set of integers includes all of the natural numbers and the number 0, but in addition, the negatives of all of those numbers. So, the number 3 is a natural number, a whole number, and an integer. The number 0 is a whole number and an integer, but it's not a natural number because it's not in that set. And the number -2 is an integer, but it's not a whole number and it's not a natural number. The next biggest set is the set of rational numbers. And these are the numbers, as we just said, which are fractions, repeating, and terminating decimals. The number 3 is a natural number, a whole number, an integer, and it is also a rational number. The number 0 is a whole number, an integer, and a rational number. The number -7 is an integer and a rational number. Other rational numbers include numbers like 3/4, 8.2, 97 over 12, and -14 over 107. Those numbers are all rational numbers. The irrational numbers, as we said, have non-repeating and non-ending decimals, and there is no connection between the irrational numbers and the rational numbers. A number is either one or the other. And all of these numbers form the set of real number. So, if it's a natural number, it's a real number. If it's a rational number, it's also a real number. And if it's an irrational number, it's also a real number.